All right, let's talk about something that's all around us, something we rely on every single second of every day, but that we almost never actually see. I'm talking about civil engineering. It's this incredible, often hidden world that literally builds our reality from the ground up.
So where do we even begin with something so massive? Well, honestly, you don't have to look far at all. In fact, you've probably already used a dozen civil engineering marvels today without even thinking about it. Just, think about how your morning started.
The second you turned on the tap for a shower or to make coffee, just like that, you connected to this massive, unbelievably complex water supply system. Getting clean, fresh water to your home and then safely taking all the wastewater away, that is a mind-boggling feat of civil engineering.
Or how about this? You flicked on a light switch. Boom. You're pulling power from the grid. And yeah, it's civil engineers who design and build the power plants and all the infrastructure that gets that electricity to you, reliably, every single day.
And then, when you headed out the door, you traveled on a whole network of roads and bridges, all managed by traffic systems trying to keep things from turning into total chaos. Yep, you guessed it. All of it planned, designed, and maintained by civil engineers. It truly is the invisible framework of our daily lives.
Now you might think this is all modern stuff, right? Not even close. Civil engineering is one of the oldest professions there is. The name itself, civil engineering, actually came about to separate it from military engineering. This isn't about building forts. This is about building civilization.
And this comparison just blows my mind. On one hand, you've got the pyramids in Egypt, built thousands of years ago. On the other, the International Space Station, literally orbiting our planet. What connects them? Civil engineers. They have always been the ones pushing the absolute limits of what we thought was possible.
So if we had to slap a formal definition on it, what would it be? Well, civil engineering is the whole shebang, the planning, the construction, and the maintenance of our entire built environment. We're talking bridges, roads, dams, airports, basically all the critical systems that make our communities actually work.
Now, as you can probably guess, civil engineering is a huge umbrella term. It's not just one job. It's broken down into a whole bunch of different specialties. So let's take a quick look at some of those key areas. You've got everything from structural engineering, that's all about the buildings themselves, to transportation and urban planning. But for this explainer, we're going to zoom in on one that is absolutely fundamental, yet is also one of the most hidden: geotechnical engineering. So what in the world is geotechnical engineering? Put simply, it's all about the ground. It's the science of understanding how soil, rock, and water are going to behave when you put something really heavy on top of them. So here's the bottom line. Before you can build a skyscraper up, you have to have a geotechnical engineer figure out what's going on down.
So what does that actually look like in the real world? It's not just some person in a hard hat kicking at some dirt. No, it's a deep science of analyzing, calculating, and sometimes even changing the very ground we plan to build on.
I mean, just look at this. You want to build a massive tunnel through a mountain or a dam to hold back a river? You can't do any of that without geotechnical engineers. They're the ones who analyze the site, figure out the properties of the soil and rock, and design the foundations to make sure the whole thing doesn't just sink or fall over.
Okay, now don't get scared by the math here, but this is so cool. This formula is a huge deal in the field. It basically helps engineers figure out how a massive weight, like from a bridge, is shared between the solid dirt particles and the water pressure that's in the soil. Getting this calculation right is literally the difference between a stable structure and a total disaster.
And what if the ground is just bad? Like, it's too soft or unstable to build on? Well, they can actually fix it. This diagram shows this wild technique called deep mixing, where they basically inject a binding agent into the soil to strengthen it. It's one of many ways they can turn completely unbuildable land into a safe place for construction.
So much of this work is completely invisible when it's done right, but its importance becomes absolutely, terrifyingly clear when things go wrong. And we're going to look at a case study that really drives home just how high the stakes are.
This was the I-35W bridge over the Mississippi River in Minneapolis. For 40 years, it was a vital transportation artery for the city. But on August 1, 2007, the unthinkable happened. It was right in the middle of the evening rush hour. Traffic was crawling. And then, suddenly, the main span of the bridge catastrophically failed, collapsing into the river below. The failure was sudden, and the consequences were absolutely devastating.
After the collapse, investigators looked back through inspection records, and what they found was just chilling. This photo, from 2003, 4 full years before the collapse, shows that key connecting plates, called gusset plates, were already visibly bent and deformed under stress.
Ultimately, a fundamental design error was at the heart of the failure. The gusset plates were simply too thin, only ½ an inch thick, and they couldn't handle the load. This critical flaw was then made worse over the years as 2 inches of concrete were added to the road surface, increasing the dead load on those already strained plates by 20%.
The I-35W collapse is a tragic reminder of why every single detail, from the steel plates in a bridge to the soil properties beneath it, is absolutely critical. And this foundational work is more important than ever as we look to the future.
The challenges of the next century. Building sustainable cities for a growing population, developing new energy infrastructure, adapting to a changing climate. All of these rely on the principles of civil engineering. They all require us to build smarter, safer, and more resiliently.
So the next time you drive over a bridge or turn on your tap, just take a moment to think about the invisible world of engineering that makes it all possible. Because everything we build depends on a solid foundation. And the question is, as we build for an uncertain future, are we paying enough attention to what lies beneath our feet?